Morning once again. I actually want to welcome you to my lecture today. Today, Mondays, September 14, 2020. Uh, I'm actually going to be walking you through another exciting topic. But let me quickly make some announcements. The first assignment of the semester will actually be uploaded today. Going to be on Monday night. And I also want to tell you, if you check the course module, I've already uploaded all lecture materials for this week and all lecture materials for next week. Okay. So those of you who want to read ahead. Okay. Now, I want to welcome you to my lecture today. Today, I actually want to introduce you to linear regression model. And of course, uh, you're going to read, can get that from chapter 1 of the recommended textbook. Okay. Um, this is going to be the outline for today. I'm actually going to walk you through regression modeling steps. And I'm also going to walk you through how we can estimate unknown parameters in a linear regression model. And that is actually going to be the focus of today. Okay, regression modeling steps. But before I go into regression modeling steps, what do I mean? What do I mean by, regression? Okay, and I'm actually going to tell you now. Oh, you remember last week I actually introduced you to what we mean by model, statistical model, how we can actually model reality. Okay. Now, and there are different kinds of model depending on the purpose. Now, in a situation where we actually want to characterize relationship between two or more variables in such a way that one variable can actually be predicted from another variable, then we call that regression. Okay. So for instance, regression analysis will enable us to identify and characterize relationship between two or more variables with an attempt to make prediction. Okay. Now, I'm actually going to cite, before I go into regression modeling steps, I'm actually going to cite an example of regression in political environment, in social environment, in economy and stuff like that. Now, let me first start from the political environment. For instance, if I want to investigate, relationship between political instability and the amount in millions of dollars a country borrow from International Monetary Fund. I'm going to say that again. Maybe we're trying to provide a practical response, to a research question that is trying to link, the amount of dollar borrowed by a country from IMF to political instability in that particular country. Of course, I can use the idea of regression modeling in that situation. Okay. Now, in that situation, I'm actually going to have independent variable that we also call predictor variable, and I'm also going to have a response. In the example that I cited right now, the explanatory variable, the predictor variable, the independent variable is actually going to be the amount of loan in millions of dollars a country borrowed from IMF. Now, the response variable that I call political instability is actually going to be the number of deaths of rioters or protesters, because in a country where there is unrest, that country will borrow more. And that is, when if a country borrow more from International Monetary Fund, that's an indication of a crisis. Now, how can we actually link the amount of money borrowed from IMF to predict political instability? Of course, we can actually use regression modeling in that regard. Are you guys hearing me?
Yep.
Okay, thanks for confirming that. Okay, so another thing that I also want to talk about, another example that I also want to talk about is in economy, where you actually want to use, probably want to look at the effect of inflation rate on the GDP. Okay, the inflation rate is actually going to be a predictor variable, and GDP is actually going to be response. Okay, we can also use regression in that regard. Now, let me go into medical area where I actually, if a patient is being admitted into an hospital, is there a way we can actually predict the length of stay in an hospital based on certain factors? Of course, when I'm doing this, I'm actually going to use regression modeling to be able to identify and characterize the kind of relationship between two or more variables. Why do I need to care? Why do I need to be? Why do I need to care about the length of stay in an hospital? Because the length, the number of days you spend, the more the number of days you spend in an hospital, the more the cost. And that is the reason why we actually need to be able to identify some factors that could, affect the length of stay. Okay, so we have so many examples that we can actually cite, but the facts remain that if we are trying to identify or characterize relationship between two or more variables with an attempt to predict a response from a given predictor or independent variable, then we are actually doing regression modeling. Now, if we're doing regression modeling, we actually need some steps. What are the steps do I need to follow? Okay, if I want to apply regression model, what are the steps, okay, that I'm actually need to follow? Number one is what I call hypothesize deterministic component. Now, let me tell you this. When you have a model, okay, you need, how do you arrive at a model in the first place? I think I told you the other time that model is as a result of our thoughts. Okay, when you have a thought about how situation work, how things work, we are actually producing a model. Okay, and you know what? The model that we are actually going to be thinking about are going to be mathematical in nature, in such a way that we need to be able to identify, hypothesize the deterministic component of the model. Now, you remember last week when I introduced you to statistical model, I told you that a statistical model there's going to be a systematic part of a model, and there's also going to be a random part. Of course, the random part is actually going to be the unexplained variation. Okay, so the systematic part is actually the model. So which is and that is the reason why people, scientists will argue that out and say, okay, when you have a model, when you specify a model, there's a deterministic part and there's a random part. Okay, so we actually need to hypothesize that. Then number two that we're actually going to do is regression model have parameters. Of course, the regression models have regression parameters. And what are parameters? Parameters are population characteristic value that we are actually seeking to determine. The moment if I'm able to estimate parameters in the model, then of course, of course, it means I'm actually, I'm on the right track in getting the information that I need. Okay, so I'm actually going to walk you through the way to estimate the unknown parameters in the regression model. And now after that, the next thing, number three, I told you that when you have a model, okay, the model has a systematic part and has a random part. And you know what? The random part, we need to know the probability distribution of the random parts that I call the error parts. Of course, we get an assumption that the probability distribution of the random part should be normal. What do I mean by that? The probability distribution of the error time has to be normal. What do I mean by that? What I mean by that is that it means the error is actually going to be well behaved, because we want a situation whereby the unexplained parts of the model will be well behaved. Okay, when we say well behaved, then we are trying, mathematically speaking, we're trying to say that the probability distribution of the error time has to be normal. And now, if the probability distribution of the error time is not normal, that's a violation of the assumption. There's something need to be done. And I'm actually going to walk you through in this course how you can actually correct that kind of scenario. Okay, so after that, the next thing we're actually going to do is a modulation. Okay, now after estimating parameters in my model, now the question now is, how do I know the model has really done the job? The only way to figure out if the model has really done the job is to be able to subject my model to diagnostic testing. Of course, I actually need to carry out a significant test on my model. Okay, like I said, if I really want to know whether the model is working or the model is adequate, we got a way to figure that out. And that's exactly what we call model evaluation. We evaluate our model. And after we have been able to find out that the model is good, then the next thing we can do is actually whatever result the model produces, then we can actually, that will form part of the policy formulation. And that was why I said we can use the model for prediction and estimation, whatever we want to do, we can actually, because we have been able to verify for assumption, we've been able to realize the model is actually good. Are you guys hearing me?
Yep.
Okay. If there is anyone in the process of explaining this, if there is anyone that have a trouble time understanding the way I'm explaining this, please, you can actually ask a question, okay? Now, the next thing I'm actually going to do now is, how do I specify a model? Because if I actually want to use a model, for my data set, I'll actually need to have a model specification. If I want to specify my model, then I need to think of what are the components of this model, because every model is actually going to have a mathematical component. Now, what are the components of this model? Of course, I'm actually need to define variables. Okay, I need to know if I'm working on regression modeling, and actually need to know what is going to be my predictor variable and what is actually going to be my response variable. In a situation where I'm working on a simple linear regression, of course, I'm actually need to specify one response and one predictor variable. But in a situation where I'm actually working on multiple linear regression, of course, I need to specify I need to specify one response variable and more than one predictors. So, because we need to get the specification of the model right to be able to capture the information that we're looking for. Okay, you now understand what I mean by specifying variable. Some of you may be working on advertising. You may be looking for the effect of advertising on the volume of sales. Okay, you need to be able to identify, oh, advertising is actually going to be my predictor. Then the volume of sales is actually going to be, response. Okay, the other time I talk about how we can actually link the amount of money the country borrow from IMF to political instability. So from that statement, I should be able to specify my response variable and my predictor variable. And that's exactly what we're trying to talk about. Okay. Now, after specifying my variables, of course, I also need to put into consideration the observational unit. Okay. I need to put it into consideration the subject, what I'm actually going to be using. Okay, that's going to be the unit of measurement. Then the next thing I'm actually going to do after defining my variables in the way to specify my model, the next step I'm actually going to do is to hypothesize nature of relationship. If I want to hypothesize the nature of relationship, hypothesize is more or less, can we guess? Can we have an intellectual guess about the nature of relationship between the two variables? And you know what? When I talk about regression, regression can be linear or non-linear. Okay? Now, when I say linear, then I means the relationship between the variable is going to be a straight line. And when I say non-linear, of course, the relationship between the variables is not going to be a straight line. Okay? And that is the reason why I actually need to hypothesize from the beginning of modeling. I actually need to hypothesize the nature of the relationship. Okay, now in hypothesizing the nature of the relationship, I actually need to be able to know what is going to be the expected signs, expected effects. Let me give you this example. There's a country in Africa called Nigeria, and that very country, the economy of that country actually depends on oil revenue. Okay, the revenue from oil and gas. Now, if I actually want to study relationship between oil revenue, between the economy, between the GDP and oil revenue, then it means the regression parameter associated with the oil revenue, even before going into research, should be positive. Okay, that's an expected effect, the expected sign. Before I go into research, we got what we call an expected signs of the regression parameter. And how do I know the expected sign? Is because I understand, you can know the expected sign if you really have what we call, if you review the literature, if you really have a background information about the area of your application. And that is the reason why I know that, okay, if I actually want to study relationship between oil revenue and the GDP of that particular country, then I know ahead of time that I should, the sign of the regression parameter associated with the oil revenue should be positive. Okay, and that's what we mean by expected sign. Okay, the next thing that I'm actually going to talk about is the functional form of the model. I need to be able to hypothesize whether the functional form of the model is actually going to be linear or non-linear. Okay, now how do I know it's going to be linear or non-linear? And that actually depends on my level or my my understanding of statistical theory. Not only my understanding of statistical theory, then I also need to know the background information of the application area. And that is the only way to be able to know whether, okay, I'm actually going to specify a linear relationship or I'm going to specify a non-linear relationship. But you know what? Whatever functional form you specify, we got a way to investigate at the end of the day whether that is a true relationship or not. We got a way to investigate that. Are you guys hearing me?
Yep.
Okay, thank you very much, because I actually need to confirm. Thank you for confirming that. Okay, so the next thing I'm actually going to talk about is interactions. There is possibility Of course, we can only talk about interaction if I'm talking about multiple linear regression where we have more than one predictor. Where two predictors could interact, okay, and we got a way to investigate that interactive effect. Okay, so when we are hypothesizing the nature of relationship, we need to put into consideration stuff like this. What is going to be the likely expected sign of the regression parameter, and what is going to be the functional form of my model? Because in a situation where the true functional form of a model is of the model, for the relationship of the model relationship between variable, if it is linear, if you actually use non-linear, if you base your recommendation on non-linear, then whatever decision you make, around that will not see the light of the day. It's not going to be valid. And that is the reason why we care a lot to be able to understand what is going to be the functional form of my model. And that is the reason why at times in the world, I told you last week, anything that exists can be modeled. If we try to model and we don't get things right, that doesn't mean a model has failed us. But what that implies is that we're not using appropriate model. Okay, and how can we use appropriate model? Then we actually need to be able to have specify a good functional form of the relationship. Okay, we need to be able to know that if it is not linear, if you specify linear, then that is not going to be good. And like I said, I'm actually going to walk you through how actually specify a good model, a good functional form of relationship. That really matters a lot. Okay, the next thing I'm actually going to talk about is if I want to have a model specification. Okay, so what do I need? That can be based on what? Of course, the theory of feed. What do I mean by theory of feed? If I want to carry out regression analysis to sociological variables, then it means I need a background information about sociology. Even if I'm in statistics, for instance, if somebody consults me to analyze sociological variables, then I don't just apply my statistical knowledge like that. I also need to have a background information about the sociological variable I'm talking about. Okay, and that is why at least I need to have a theory. I need to have the theory. I need to understand certain theory in the field of sociology. Okay, and that's why I'm giving that as an example. In addition to statistical theory, I also need to understand, I need to have a basic information, the background information from that very area of application. Okay, the next thing that I'm actually going to talk about is mathematical theory. In the specification of a model, of course, I need to have the knowledge of mathematical theory. I need to be able to know what is the functional form of, if I want to specify a linear model, how does it look like? And that was the reason why in your high school, I know you have come across what we mean by a linear equation, nonlinear equation and stuff like that. So that by the time you want to specify a linear model, you actually understand the mathematics, okay, the mathematical theory behind that. So in regression modeling, of course, you need to be able to display your mathematical understanding of relationship as well. Now, the next thing, if I want to specify a model, okay, what is actually going to guide me in specifying a good model is going to be the theory of the field, then my knowledge of mathematical theory, and the next thing I'm also going to talk about is previous research. If I want to conduct a research on the length of stay in hospital by patients, in relation to certain factors, then I'm actually going to search Google. I'm actually going to search publications. I want to see whether, those who have worked in that area before, what kind of model did they use? That may give me the idea of my starting point. Are you guys hearing me?
Yes.
Okay, thank you. If you guys are hearing me clearly, I want you to say yes, or you just say, or you can say yes in the chat. I want to see a good number of people saying yes if you are hearing me clearly. Oh my God, good job. Thank you, thank you, thank you so much. You guys are good. Okay, so like I said, I need to be able to revisit the internet. I need to be able to revisit previous research in that area to be able to have the understanding of how the model is actually going to be. And that is the reason why I said previous research. Okay. Now, the next thing that I'm also going to talk about is actually going to be common sense. I'm actually going to apply common sense in a situation whereby I don't have access to previous research. Okay, I don't have access to previous research, or maybe a research of that nature has not been conducted in the past. Okay, so if the research of that nature have not been conducted in the past, then what I'm actually going to use my common sense. And of course, we got a way to investigate the common sense. We got a way to investigate the model at the end of the day, whether the model is good or the model is bad. We got a way to investigate that. So what I'm just displaying right now, these are 4 ways, we can actually base our model specification on. Okay, if you really want to have the right functional form of a model, if you really want to, correctly specify the model, the regression model, of course, we're actually going to go through this. Okay. The next thing that I want to talk about right now, I'm actually having a thinking challenge right here. Now we want to go into regression modeling, and this time around, we're going to be visiting. Let me first tell you this. We got 2 types of regression model. We got a simple. Let me say we got 2 types of regression model. We got a linear regression model. We got a non-linear regression model. I'm going to say that again. We got 2 types of regression model. We got linear and we got non-linear. Okay, the linear is just telling us that, okay, relationship between the variables have to be a straight line. This is an example of a linear model, linear regression model. Can you see that? This and that are example of a linear regression model. Okay, and this and that are example of non-linear regression model. These are non-linear and these are linear in nature. And we have different kinds of non-linear regression model. Okay. And you know what? In linear regression model, the one I call a straight line, we have a simple linear regression. We got a multiple linear regression. The simple linear regression is when we have a response and one predictor. But the multiple linear regression is where we have one response and we got more than one predictors. But the one I'm trying to showcase right now, this is an example of a simple linear regression, okay? This is an example of a simple linear regression because I'm only looking at the relationship between sales and advertising. Sales here is actually going to be response, and advertising is actually going to be predictor. It means I got one predictor, okay? And if you take a look at what this guy is trying to tell me right here, this is more or less like a positive slope. I'm actually going to get a positive slope from this. So this is actually, the positive slope is actually telling us, when you are trying to look at the if the relationship between sales and advertising is linear, and it is if it is this, then what I'm trying to say, when the amount I spend on advertising increases, then the volume of sales is actually going to increase. So it means the volume of sales and advertising, they're actually moving in the same direction. But what this guy is actually telling me here is that sales is inversely related to advertising. So which means if I spend more money on advertising, then I'm actually going to record low level of sales. That is what this is trying to tell us. But when you take a look at what I have right here, when you take a look at what I have right here, so what I have right here is just trying to say, okay, there's going to be an increase from the one, and it's actually going to get to a point that things are likely to, plateau, okay? And that's exactly what we, if you take a look at the pandemics that we find ourselves into in the world, I'm trying to talk about COVID-19, okay? What the effort of every country in the world is that, okay, the intervention should be able to flatten the curve. We don't want a situation whereby it's going to continue to increase like that exponentially. We want a situation whereby it's going to get to a point that the point of maximum reach, and after getting to the point of maximum reach, is actually going to be going down in a way. Okay, now I want to ask a question, and if you take a look at what I have right here, it started increasing and it get to a point that is stabilized for so many. You can see that now. Now let me have a thinking challenge. Right now, I want to award an extra credit. Can somebody tell me which one do you think is more logical? And you need to tell me the reason why you believe the one you choose is more logical among these four charts. Can somebody tell me which one is more logical for extra credits? Yeah, somebody said the third one. If you say the third one, I need you to tell me the reason why you believe so. What is the reason? Why do you say the third one? For you to have your extra credit. Why do you say the third one? Are you guys hearing me? Okay. So I need to know the reason. The person that chose the third one, you actually need to tell me. I need to know the reason why you believe it's actually going to be the third one.
Hello?
Okay, yeah, I'm hearing you.
It would be the third one because sales wouldn't increase forever. It's likely that if you spent X amount of money on advertising, there would be a response, but then it wouldn't continue indefinitely.
It won't continue indefinitely. Oh my God, look at me. This is an applause for you. Good job, good job. Now, you know what I need you to do right now? Send a message to me for extra credits indicating you are in section 001 of star 3022. Did you hear that?
Could you repeat that?
Yeah, I'll send a message to me for extra credit. You send it to my email because the extra credits will actually be counted towards your grade. Does that make sense?
Yep, sweet.
Okay. Now, based on what he said, we don't expect the volume, the volume of sales to increase indefinitely. Okay, we don't expect that. That is what is more logical. You get what I mean? Okay, so but let me tell you this. If I really want to know the relationship, the functional form of the relationship between two variables, if I want to know that, then I'm actually going to have a plot. And when I have a plot, what do I mean by having a plot? I'm actually going to plot the response variable against the predictor variable. And when I do the plotting, of course, I'm actually going to see the shape. I'm actually going to see the shape of that relationship, whether it's going to be a straight line, whether it's going to be a curve, whether it's going to be. So whatever shape that come up, and that is what I'm going to specify in my model. Okay, my model must reflect the functional relationship between the two variables. Okay, and how do I know that? I'm actually need to, do what we call a data exploratory analysis like this. And this is exactly what we call a preliminary investigation that need to be done in order to be able to ascertain about the functional form of the relationship between the two variables under investigation. Okay. Now, I'm actually going to go into types of relationship now. Let me tell you this. In regression analysis, particularly when we are working on a simple linear regression model, okay? If you are working on a simple linear regression model, we actually need to denote the response variable as y. There's going to be a response variable, and x. X is a symbolic representation of the predictor. Okay. Now, there's what we call a scatter diagram. Scatter diagram. The scatter diagram is a diagrammatical plotting of the response against the predictor variable. Now, when I have two variables, and I'm seeking to understand the kind of relationship, the functional form of the relationship between the two variables. Of course, when I plotted, I'm actually going to have something like this. You're going to have, if you take a look at this line right here, the solid line, the black solid line is the line of, I'm going to call that line the line of equal distribution. I don't expect all the points to be on that line. If all the points are on that line, then I'm trying to talk about perfect relationship. There is no perfect relationship anywhere in the world. Okay? If a relationship exists between two variables, it's not going to be perfect, and we don't, and that is the reason why we're going to have some points that are scattered away. And that's why you see that all these points here, they scattered away. Okay, but you know what? If you see the dotted line right here, and you see the dotted line right here, it's trying to tell us the distance from the point to the line of equal distribution. And what are we looking for? We are actually want a situation whereby, point will not be far away from the line of equal distribution. Because if the points are far away from the line of equal distribution, then what we are trying to talk about is that's going to be a problem. Okay, there's going to be a problem. So in a situation where you have this kind of shape, of course, this is indicating a strong relationship. That is indicating a strong relationship, because when we're talking about relationship between two variables, it could be strong, it could be weak. And not only that, it could be strong or weak. Okay, the relationship could be a negative one, it could be positive one. Now, this is an example of a strong relationship. And if you take a look at this guy right here, this is an example of a weak relationship. Though relationship exists, but if you look at some point, they are far away from this particular line of equal distribution. If you look at the level of disparity, the level of expansion of the data point away from the line of equal distribution right here is very, very huge compared to this. This is how to show an example of a strong relationship, and this is how to show an example of a weak relationship. Can you guys hear me?
Yeah. Sorry, can I ask a question?
Okay, go ahead.
It's not about the material. Is it stats 5021 or not?
Oh, this is 3022.
Oh, sorry. I just saw this link on Canvas. I think I'm just in the wrong class.
Oh, okay. The 3021 is going to be at 2:30. Does that make sense?
Yeah. Well, 5021 is asynchronously, right? So there's no actually.
You're talking about 5021, right?
Yeah, statistical analysis. Yes.
Oh, 5021 is aired asynchronously.
Okay. Yeah, I think I'm in the wrong class.
And you know what? The lecture for today for 5021 has already been uploaded. Did you see that on your module?
Yeah.
Okay. Good job.
All right. Thank you.
You're welcome.
Bye bye.
Okay. Are you guys hear me?
Yep.
Okay. You know what? This is not a lecture. I'm going to call this a party. Okay. We are having a statistical party right now. Okay. So let's have some fun. Okay. For those of you who do not really understand, please ask questions. Okay. Now, I've been able to showcase what it takes to have what it takes a linear relationship to be strong, and what it takes a linear relationship to be weak. Now, the next thing that I actually want to talk about is, if you take a look at this guy here and this guy here, is an example of a positive relationship. A positive relationship could be strong and it could be weak. Okay. Now, if you take a look at this guy here and this guy here, these two, this is a strong relationship as well, but this is a negative relationship. Negative relationship in the sense that when S increases, Y is actually going to move in a different direction. Okay. But if you take a look at this guy right here, when X and Y, they're going to move in the same direction. That's a positive relationship right here. Okay, this is a positive relationship. This is a negative relationship, but these two relationships right here are strong. We can have a positive relationship that's a strong one. We can actually have a negative relationship that's also a strong one. Okay, but when you take a look at this side, these two are an example of weak relationship, only that this guy here is a positive weak relationship, and why this guy here is a negative weak relationship. Now, when you have a data set on two variables, Y and X, one response, the other one predictor, and you collected that, over a sample size, okay, when you, if you really want to understand the kind of relationship between them, of course, you can actually do what I call a scatter diagram. So a scatter diagram, a scatter plot is a diagrammatical plotting of, dependent variable, the one I call the response variable, against the independent variable. Does that make sense to everyone? Like I said, we're having a mass party, okay? Statistics party. Okay, if you take a look at what I want to show right now, you're going to see that this is not looking like a diagonal straight line. This is here a straight line, but this is an horizontal straight line. Okay, in a situation where you got an horizontal straight line, okay, then it means there is no relationship. We could have situation where there is no relationship. Okay, so either this or this is indicating no relationship. And what do I mean by no relationship? What I mean by no relationship is just that when S increases or it decreases, Y, it will be unaffected. Whatever that happens to the predictor will not have any effect on the response. That is what we mean by no relationship. Okay, so no relationship when a predictor increases or decreases, the value of the response is not going to be affected. Another example of no relationship. So what I've done so far, I've been able to by having a direct plotting of the response variable against the independent variable, you'll be able to know whether you have a strong relationship or a weak relationship, or whether the relationship is actually going to be a positive one or whether it's going to be a negative one. Okay. I want to go into types of regression model, just like what I talked about the other time. We are on regression models. When we talk about regression models, what are the types of regression model? Number one, we got a simple linear, we got a simple regression model. I'm going to say simple regression model. And why is it simple regression model? Because you only have one explanatory variable or one predictor variable, okay? Now, and when I talk about simple regression model could be divided into linear or non-linear. So we could have simple linear regression, we could have simple non-linear regression. Now, what do I mean by simple linear regression? The simple linear regression is just like, okay, I'm trying to assume a straight line relationship between two variables, where one is a response and the other one is actually going to be predictor. But when I talk about a simple non-linear relationship, the simple non-linear relationship is actually going to tell us that we are trying to hypothesize a non-linear relationship between two variables, one predictor and a response. Okay, I'm actually going to work, this is what we're going to be doing in this course. I'm going to walk you through what we mean by simple linear regression, what we mean by non-linear, simple non-linear regression. Then another one is what when you have more than one explanatory variable, and that is what we're going to call multiple. Okay, we can have a multiple linear regression. We also have a multiple non-linear regression. Look at that. Those are the models. Those are the regression models that we're also going to be talking about in this course. Okay. So now I want to introduce you to simple linear regression right now. You know, like I said, we want to start this simple linear regression. That's what we're going to do. If you take a look at the model that I have here, we got 4 models. Okay. Generally, we could talk about simple linear regression. We could talk about simple nonlinear regression. We could talk about multiple linear regression. We could talk about multiple nonlinear regression. But only that in nonlinear regression, there are so many types of nonlinear regression. But you know what? What I'm starting with right now, I'm actually starting from simple linear regression. Okay? I'm going to start from simple linear regression. Now, I'm actually going to stop here today. Next time on Wednesday, I'm actually going to start from simple linear regression, where I'm going to review the model to you. You know, what is parameter? What is a parameter in the model? What is a variables in the model? And what is a random component? I'm actually going to start from here on Wednesday. Is there anyone who want to ask question? Is there anyone? Now, there's something I'm actually going to be doing. If you understand what I've reviewed and what I've explained today, I need you to chat yes. If you don't understand, then I need you to signify no. But don't forget, tomorrow, I'm actually going to have my office hour for those who need one clarification or the other. The first office hour of the semester will be held tomorrow. Like I said, I want you to be an expert in this course. And that is the reason why I need you to, anytime if you get stuck with anything, please do not hide your feelings. Now, from Wednesday, I'm actually going to start from here, and I'm going to be walking you through, you know, models. I'm actually going to be telling you, okay, in this model, this is what this and stuff like that. That's what we're going to be doing. Okay. And from there, we're going to talk about estimating parameters in the model. And from there, we're going to go through, after estimating parameters in the model, then I'm going to walk you through model evaluation. How do we investigate? How do we know this model will do the job? How do we subject model to diagnostic testing? Okay, and stuff like that. Those are the things I'm actually going to be walking you through. Okay, I want to thank everyone for attending my lecture today. I want to also remind you that the first assignment for the semester will be uploaded today, Monday night, and it's actually going to be due for submission Sunday night. Make sure you also check the course syllabus. It has been updated. On the course syllabus, you're going to see topics that we're going to cover in this semester, and you're actually going to see some important deadlines about practical assignment, about assignment, then some exam dates. You know, all those are already published on the course syllabus. So check that for updates. And of course, the video for this this video is being recorded, and I'm actually going to share this video with a student at the end of the day. I want to thank everyone. Yeah, somebody said the assignment has not been posted yet. Yeah, if you look at my syllabus, I said the assignment will be uploaded every Monday night, and it will be due for submission every Sunday night. So I want to thank everyone for attending my lecture. I hope you guys enjoyed that. You guys should make sure you stay safe and do have a good day.
Thank you. You too.
You're welcome.
Thank you.
You're welcome.
Thank you.
You're welcome.
Thank you.
You're welcome.